Hi, my name is Bill Furch. I am a volunteer docent at the Space Foundation Discovery Center in Colorado Springs, Colorado. Today we are going to discuss one of our largest artifacts on display, the SpaceLab training module. SpaceLab was a follow-on program to the Mercury, Gemini, Apollo, and Skylab spacecraft programs. The Mercury spacecraft could only hold one astronaut with very limited mobility. The Gemini spacecraft held two astronauts, and at least on one occasion, an astronaut did an extravehicular walk in space. The Apollo spacecraft held three astronauts, and there was some room for moving around. The Skylab could hold several, and there was some room for doing some limited experiments. SpaceLab was a natural follow-on to provide more space for several astronauts and experiments as we learned how to operate in zero gravity. This was to prepare us for building the International Space Station, which is still in orbit and being operated by several countries. SpaceLab was designed and built by 10 nations of the European Space Agency, or ESA, as the United States National Aeronautics and Space Administration, or NASA, was designing and building the Space Shuttle, a reusable spacecraft that launched into space on a rocket and then returned and landed like an airplane. SpaceLab and the shuttle were designed to operate together. This was at the time the largest and most comprehensive multinational space project. The SpaceLab was designed to fit inside the storage area of the space shuttle like this. The doors would then be closed and the shuttle would be sent into orbit.
As we move into orbit, our vision clears. Now we can go back again and again, learning from each flight experience, accumulating new knowledge. We have a new generation of orbiting laboratories. We have SpaceLab.
Once in orbit, the shuttle doors could be opened and the pressurized SpaceLab would be exposed to outer space conditions. Two SpaceLab flight units were built. A third non-flight unit was built for engineering development and training of ESA and NASA astronauts. The two flight units were flown a total of 16 times on various shuttles between 1983 and 1998, at which time the mission was transferred to the International Space Station. Experiments were conducted in the areas of life sciences, material science, physics, and astronomy during the flights. There was a tunnel that connected the shuttle cockpit to the SpaceLab, and astronauts would crawl through the tunnel to work in the lab. Each SpaceLab would be configured before flight with all the instruments and materials needed to conduct experiments while in orbit. Let's take a look inside the SpaceLab on display at the Discovery Center. After the flight, the equipment could be taken out and replaced with other equipment for other experiments. After the program ended, one of the flight units was taken to the Smithsonian Museum in Washington, D.C. to be displayed. The second flight unit is displayed at the ESA Museum in Cologne, Germany, and the third engineering development unit is this one displayed here at the Space Foundation Discovery Center in Colorado Springs. There were also several pallets designed for mounting other experiments outside the SpaceLab pressurized module. With the launch of the Mercury flights, NASA began to learn how man could operate in a weightless environment, otherwise known as zero-G, where G equals the acceleration of gravity on the surface of the Earth. Each successive program added knowledge, including how astronauts could maneuver themselves in zero-G, as this would be a requirement for assembling the future International Space Station. Other big questions that needed answers were how the human anatomy would react to zero-G. For instance, what happens to body fluids in this environment? Will an astronaut stretch out? Turns out they do. Will they experience bone and mineral loss? Answer, yes. What is the impact to the cardiovascular system? What about long-term exposure to the sun's radiation, from which we are mostly protected on the Earth's surface? Could this exposure change an astronaut's DNA? Turns out it does. What about being socially isolated from the rest of the Earth for long durations? What happens if an astronaut gets seriously ill during a mission? Can we provide the right types of food to keep astronauts healthy during long-duration flights? It turns out food spoils faster in zero-G because bacteria growth speed is increased, and bacteria are more resistant to antibiotics in orbit. SpaceLab was designed to begin answering questions and more. There are important facts to know before we undertake long-duration missions to the Moon and Mars. So what makes this artifact interesting to me personally? Well, you know, when you go to an aviation museum, you get to see airplanes that have been flown in the past or perhaps are even still flying today. But in the Discovery Center, most of the rocket and spacecraft artifacts are models because the actual spacecraft were sent on missions and never returned. An example of this is our Viking Mars lander artifact shown in the Discovery Center. It is an exact full-scale model of the two Viking landers that are still sitting on Mars. SpaceLab is different. Even though the SpaceLab being displayed at the Discovery Center never went into orbit, it is an exact equivalent of the two other SpaceLabs that did go into orbit. So as you stand on the platform and look into the SpaceLab, it is easy to imagine astronauts floating around inside as they go about conducting various experiments. By the way, the Discovery Center does have a few artifacts that have gone out and returned, such as a shuttle solid rocket booster segment, which has flown in space 4 times, the SPIFEX robotic arm, and the Scott Carpenter underwater research vehicle. I hope you will take the time to come and view them personally.